everyone. Today we will discuss class 12 esip PCM chemistry class test 7. Topic was carbonyl compounds and carboxylic acid. Okay. Our first question is on reductive ozonolysis yields. Okay. So this is the compound given. Okay. So this is the CH3. Okay. So in that case, reductive ozonolysis, if I did, so in that case, this will be this bond will be dissociated, and there will be O and O. Okay. So you will getting this compound. Okay. So its name will be 1, 2, 3, 4, 5, 6, and 7. So this name will should be 6 oxo because of 6 में ketone है. That's why 6 oxo heptanyl. Heptanyl. Okay, so this will be the name. Okay, so option will be option question number 1. Option will be A. Okay, A will be the correct answer. Next, question number 2. The end product of the following sequence of reaction is CH triple bond CH 1% HgSO4 and 20% H2SO4. So you will get what? Now you will get acetaldehyde CH3CHO. After that, if I use Grignard reagent CH3MgX, so you will get this one. Okay. So after that oxidation is done, then you will get a ketone. Okay, because this is a 2-degree alcohol. Okay, so this is a 2-degree alcohol. Okay, so that's why the answer will be acetone. This compound's name is what? Acetone. Okay, so that's why our answer should be C. Answer should be C. Next, question number 3. Okay, identify the reactant X and the product Y. The compound is CH3, C double bonded O CH3 plus X. Then we will get this one CH3 whole 3C OMgCl, and after hydrolysis it should be triple bond triple OH CH3 OH. Okay, so we should get this one and MgOH Cl. So this is the Y. Okay, so Y will be this. So CH3 Mg, if I said X means what? X will be CH3 MgCl. Okay, CH3 MgCl. So option should be C. X equal to CH3 MgCl, and Y should be CH3 whole 3 COH. So this is the option. Okay. Next, question number 4. Which one of the following pair is not correctly matched? Okay. So first one is Clemenson reduction. What is the reagent of Clemenson reduction? Clemenson reduction reagent is zinc Hg par HCl. This is the Clemenson reduction reagent. Okay, so which is not correct. They are saying not correct. Okay, so this is the correct thing. If we use Clemenson reduction reagent, it can reduce aldehyde or ketone to corresponding its alkane. Okay, so you are getting the right product. So option A is correct. Okay, next option B. Option B is called Wolff-Kishner reduction. So reagent should be NH2-NH2. Okay. Reagent should be hydrogen. Okay. So in that case, hydrogen it can reduce alcohol, ketone or aldehyde to corresponding its alkane. But they are given here. It is alcohol. So option B is the wrong product. Okay. So in that case, our answer should be option B. Okay, rest of the options we are going through. So option C, Rosenman reduction. Rosenman reduction reagent is what? Hydrogen, palladium, barium sulfate. Okay, so in that case, Rosenman reduction is doing what? Acid chloride to aldehyde. Okay, it's correct. And option D is saying Stephen reduction. Reduction is what? SnCl2 per HCl. Stephen reduction reagent, and it can CN triple cyanide to, it can go cyanide to aldehyde. Okay, so all the A, C, and D are correct. Only B, which should be getting alkane, but we are getting here alcohol. That's why B is the wrong product. So option B. Okay, fourth one will be option B. Next, fifth one. Okay, so in case of fifth one, the below reaction is called which type of reaction? Hydrogen, palladium, barium, sulfate. So it should be five. Should be C, Rosenmund reduction, because hydrogen, palladium, barium, sulfate. So this is the Rosenmund reduction. Rosenmund reduction. Okay, reaction. Rosenmund reaction. Okay, next question number 6. Which of the following compound will undergo the self condensation in the presence of cold dilute alkali? Okay, which of the following compound will undergo self aldol condensation? So self aldol condensation can getting only option B. Why option B? Because there will be alpha hydrogen CH3 CH2 CHO. Okay, so this is the aldehydic part, and this carbon is called alpha carbon. Okay, and this alpha carbon linked hydrogens are called alpha hydrogen. Okay, so we are getting alpha hydrogen in option B. That's why the correct option should be option B. Okay, next one, 7th. Benzaldehyde reacts with NaOH. Okay, benzaldehyde CHO reacts with NaOH. NaOH. We will get alcohol, benzyl alcohol, CH2OH. Okay, so we'll get CH2H. So it should be option A. Okay, 7 should be option A. Next, eighth one. Okay, eighth one is this one, this compound CHO. Okay, does not show aldol condensation because, okay, so this can't be showing aldol condensation because of absence of alpha hydrogen, because this carbon is called alpha carbon, right? Alpha carbon, this carbon is called alpha carbon, and as because alpha carbon doesn't have any alpha hydrogen, have any alpha hydrogen, that's why that's why aldol reaction can't be possible. Okay, so that's why our option should be B. 8 option should be B. Okay, next, ninth. Question number 9. Which of the following does not turn Schiff's reagent to pink? Okay, Schiff's reagent to pink can be showing by aldehyde only. Okay, so option A, formaldehyde. Option A is formaldehyde, HCHO. Okay, it can show obviously. Option B, called benzaldehyde, PHCHO. Okay, it can also show because it is also an aldehyde. C is acetone, so it is the answer. Okay, C is the acetone. So this is not aldehyde, this is acetone. And D is called what? Na acetaldehyde. Acetaldehyde means CH3CHO. Okay, so this is another aldehyde. So all the aldehydes are showing uh, shifts reagent to pink, but only ketone is not showing the shift reagent to pink. Okay, so answer should be C. Okay, 10. Which compound would give 5 keto 2 methyl hexanal upon ozonolysis? Okay, 5 keto 5 keto 2 methyl hexanal, 2 methyl hexanal. Okay, okay, 5 keto 2 methyl hexanal. We should draw the structure first. Okay, hexanal. So aldehyde is first. Okay, so aldehyde first carbon. So 5 keto 2 methyl hexane. 1, 2, 3, 4, 5, 6. Okay. So 5 position में there will be a ketone group. Okay. There will be a keto group, and 2 positions there will be a methyl. 2 position there will be a methyl. Okay. So this compound should be getting. Okay. So this compound can be getting from option number D. Okay, why? Because option number D is called CH3 double bond here. This is CH3. Okay. So if I do reductive ozonolysis, so reductive ozonolysis doing what? Now reductive ozonolysis can break this bond, and we will get, there will be an oxygen, there will be another oxygen. So CH3 double bond O. This. So 1, 2, 3, 4, 5, 6. Okay. So 2 methyl, 5 keto. This is also 5 keto 2 methyl hexamide. So similar structure. Okay. So option D is our answer. Okay. Next question number 11. Okay. The major product obtained the following reaction is. The major product obtained in the following reaction is. Okay. Okay. So we should draw the structure first. COH. There is oxygen, ketone, this, and if we use diable H, diable H full form is diisobutyl aluminum hydride. Okay, so this is the diable H. Diable H, the work of diable H is basically hydride donor. Okay, it can donate H minus. Okay, so in that case, it can reduce this COH, and it can also reduce A star. Okay, how it can reduce? It can reduce like there is a H minus ion donor here, this position, and also this position. Okay, not this position. Basically, this is a O minus, and in case of solution, you will get the hydrogen ions. Okay, so you will get the product of this. OH, and this is a CHO. Okay, and there will be a reduction, so it should be, if hydrate will be donated, so it can be CHO. Okay, so it should be reduced, right? COH, the one step behind reduction will be COH comes to CHO. Okay, so this is be the product. This will be the product. Okay, if this will be the product, then our answer should be A. Okay, so A will be our answer. Next, question number 12. Chlorobenzene reacts with trichloroacetaldehyde in the presence of H2SO4. Chlorobenzene reacts with trichloroacetaldehyde. Okay, so we will write the diagram like this way so that we can get our product. Plus so after that, if H2SO4 are giving, so H2SO4 is a dehydrating agent, so minus H2O. Okay, then our product should be this. So this is the product. So this will be option number C. Okay. Next, question number 13. Okay. In question number 13, the appropriate reagent for the following transformation. Okay, appropriate reagent. So the thing is, if we use option C, hydrogen nickel, it can do what? It can do alkane. Okay, corresponding alkane it can do. Okay, and sodium borohydride also doing what? Alkane. For that ketone. Okay, for that ketone it can convert to alkane. So sodium borohydride and hydrogen nickel. Okay, hydrogen per nickel. So this can do what? This can also do alkane, as well as this can also do basically alcohol. Okay, hydrogen and nickel basically doing alcohol, and CH2 CHO basically. Question number 13. This is the structure, CH3 and OH. So if we react this compound with hydrogen nickel, H2 or Ni, so what we are getting, if I do that, so it will be converted into alcohol. Okay. Or if I said if I use sodium borohydride, NaBH4 also, or NaBH4, it can also do what? Alcohol. But we need what? We need basically alkane. This OH completely removed. It can be removed by option A, zinc Hg per HCl, means Clemenson reduction, and option B, NH2 NH2 OH minus Wolff-Kishner. But the thing is, option A doing what? Now zinc Hg per HCl doing this OH. This OH also reacts with zinc Hg per HCl. Okay, this HCl also reacts with this OH. Okay, and it will be H2O plus, and it will be also converted. But in the final product, our product should be this. Okay, OH must be present, है ना? So in that case, we have to use option B. Why? Because there is a basic medium. Okay, hydrogen NH2 NH2 hydrogen reacts with OH minus. So 13 answer should be option B. Okay. So HCl we can't use because of OH will be gets reduced. Uh, in case of hydrogen nickel or sodium borohydride, it can convert ketone to alcohol. That's why. Okay, next question number 14. Question number 14. CHO. Here is a CHO, and here is another CHO. Here is another CHO. Here is another CHO. So first one is NaOH, 100 degrees Celsius, 2H plus per H2. Okay. So this CHO gets, if I said this CHO OH minus first attack on this CHO, and there will be hydride shift, means like Cannizzaro. Okay. So hydride shift, so it should be, the product should be this. Product should be this. CH2OH, and another will be COOH. Here also COOH and CH2OH. Okay, so this should be our product. So the product should be D. Okay, next question number 15. Okay, in question number 15, EFG, we need to say what is E, what will be F, what will be G. So EH, C double bonded O, there is a OH, double bond O, there is a star. Okay, if we heat it up, so if we heat, so if we give heat, so it will be carbon dioxide. Okay, so in that case, This bond will be removed, right? So we are getting pH. So if carbon dioxide is removed and we are getting pH C double bonded O, and there is a CH3 and there will be a star mark. Okay. And after that, if I use iodine per NaOH, iodine per NaOH means iodoform test is performed. Okay. If we perform the iodoform test, so we will get pH C double bonded O, O minus Na plus CH I3 star. Okay. CHI3 star. So this is the F and this will be G. Okay. We can say this is our E. Hmm. So in that case, our option should be C. 15 option should be C. Okay. Next, question number 16. In question number 16, if we use HNO3 H2SO4, so HNO3 H2SO4 means there will be electrophile is NO2 plus. Electrophile should be NO2 plus. This is our electrophile. Okay. So this electrophile can be attached at the uh, at which position? Okay. So we need to say that. Hmm? Okay. This is C double bond O. Okay. So if NO2 plus will be there, so this group is basically electron withdrawing group, EWG, electron withdrawing group. Electron withdrawing group is what? Doing what? So it can withdraw the electron. So already this benzene ring having less electron density. Okay, that's why electropositive or electrophile NO2 can't attach this position. But here this oxygen can electron donate, right? So if it can donate the electrons, so we will get the product this. NO2 and oxygen C double bond O and this will be our product. So option C is the right option. Okay. Next, 17. Question number 17. So in question number 17, this benzene ring needs to go C double O H and NO2. Okay, how it can goes to here. So if we use firstly CH3Cl and AlCl3, CH3Cl and AlCl3, so this is the Friedel-Crafts reaction, Friedel-Crafts alkylation reaction. So methyl will be there. Okay. After that, if we use KMNO4 and H plus, KMNO4 H plus, so COOH can form. Okay. After COOH H plus, some heating should be given here. And after that, if I use mixed acid or mixed acid, okay, mixed acid HNO3 H2SO, so we will get our final product. So our option should be B. Okay, option should be B. CH3Cl, AlCl3, Ka1O4, H plus, heat, and HNO3 and H2SO. So our option should be B. Just a second. Yes, our option should be B. Next, question number 18. PHCO NH2, PH C double bond O NH2. If we use dehydrating agent means here P2O5. So it will be removing this H2O. Okay. So this H2O will be removed. So in that case, our product should be PHC triple bond N. Okay. So option D is our product. Question number 19. Consider the following compound. Okay. the correct order of reactivity towards hydrolysis is? Towards hydrolysis. So, hydrolysis order should be highest for option 2. Why? Because in case of option 2, that NO2 group basically withdraws the electron from the benzene ring. So, carbonyl carbon having delta positive charge density is very high. That's why there the for hydrolysis OH will be attacked and chlorine will be replaced. Okay, so in that case option 2's reactivity is very high. After that it should be 4. Why it should be 4? Because in case of 4 uh, we are getting CHO at para position. With respect to COCl, CHO is in para position. So CHO is also behaving like a electron withdrawing group. Okay. Next, after 4, it should be 1. Why? Because there will be no electron withdrawing groups. Okay. After that, it should be 3. Okay. Why 3? Because it can donate electron pair. Okay. That's why option 3. Okay. So this will be option C. Okay. 19th answer should be option C. Next, 20. Question number 20. Which one of the following on treatment with 50% aqueous yields the corresponding alcohol and acid? Okay. Which one of the following treatment with 50% aqueous NaOH? Corresponding alcohol and acid. This is a simple candy zero. So C6H5CHO. Okay. So option E will be the answer. Okay. It's very simple. Question number 21. Okay. How many of the following doesn't give iodoform test? Okay. So CH iodoform test given by this compound, right? If this group will be present, CH3COZ. Okay. So if this group is present, then it can shows the iodoform test, or we can say CH3, CH, okay, OH and Z. This group also shows the iodoform test. Okay. So in that case, CH2OH it can show, but CH3OH, CH3OH can't, because this group is not belonging from this group. Okay, so that's why we can say, so this one can't show. And then CH3CHO again can show iodoform test. Again PHCOCH3 it can also show. Okay, so our option should be CH3OH. Okay, so only answer should be, this is a numerical type question, so its answer should be 1. Okay. Question number 22. How many functional group is or are oxidized? Okay. So PCC, if we use PCC, PCC is a very mild oxidizing agent. Okay. So it is a very mild, as because it is a very mild oxidizing agent, and as because this group, I will draw first. O C double O CH3, and there is a OH. If we use PCC and CHCl3, so it can oxidize this group only. Okay, so that's why how many functional group can be oxidized? So only one functional group can be oxidized. Okay, it will be the product should be like this. Okay, product should be like this, CHO, and rest of the things are there. Okay, there is a OH, and rest of the things is as it is. Okay, so this is the changes. Okay, so only one functional group like alcohol converted to aldehyde. So its answer also 1. This numerical type question. Next, question number 23. How many number of HCHO molecule are reacting to give the major product? Okay, so this is a very important question. Like if I say pH, C double bond O, and there is a CH3 and hydrogen. And initially, if we use NaOH, initially we are using NaOH, then the conjugate base be like this. Okay, So if this is the conjugate base, then this conjugate base is reacting with another molecule of HCHO. Okay, if it reacting with this, so you are getting this one is the product PH C double bond O, again C CH3 and then CH2O minus. Right now, no alpha hydrogen is there. Okay, so in that case, cross aldol condensation reaction is not happen. Right now, what will happen? Right now, Cannizzaro reaction will happen. Okay, so in that case, HCHO. So this is the first molecule of HCHO is reacting. This is the first molecule of HCHO is reacting. Again, if we are using HCHO, so HCHO Cannizzaro reaction. So HCHO first react first. Why? Because that can be donated hydride, right? So HC uh, HO. Hmm. HCHO. I should write like this way. Hmm. I should write it. This is a two type of reactions. So one will be oxidation, another will be reduction. Okay. So oxidation product should be HCOO minus, and reduction product is PH CHOH CH2 CH2 CH2OH. Okay, so this is the second molecule of reacting. Okay, and they are giving another HCHO. So this is the first HCHO. Okay, so now this is the first HCHO. This will be second HCHO. Okay, second HCHO is reacting with second HCHO. We should write here second molecule of HCHO. After that, this one reacting with another molecule of HCHO, HCH double bond O plus OH. This is another OH. We should write like this way so that our product area will understand. This is the H2O molecule. Okay, if we removing this H2O, so our product should be O, O, this one, this one, this one, this one, this H3, pH. Okay, so this will be our final product. Okay, so how many number of HCH molecules are reacting? So three molecules are reacting. Okay, three molecules of HCH are reacting. Why three? Because this is the third one. Okay, so this is it. Next, question number 24. Question number 24, the DBE for the following product. Okay, DBE for the following product. So product will be this, because this is a dehydrating agent. So DBE should be 1, 2, 3. Okay, so DBE should be 3. So answer will be 3. Okay, next question number 25. How many carbon dioxide molecule can release? Okay, after heating. So after heating, we will get this one is the product. So how many carbon dioxide will be released? 2 carbon dioxide. So here one carbon dioxide, here is another one. So answer should be 2. Next, question number 26. Propionic acid with bromine phosphorus yields a product. How many alpha hydrogen replaced? Okay, by bromine. Propionic acid, methith prop, propionic acid. If we are using bromine, we are to per phosphorus, so we will get this product. This one is the product, bromine. Okay. So how many alpha hydrogens are replaced here? How many alpha hydrogens are there? Alpha hydrogen is basically 2. Okay. Next, 27. Consider the following reaction: hydrogen, palladium, barium sulfate. If we are using COCl, hydrogen, palladium, barium sulfate, so we are getting CHO. So dB should be 3 plus 1, 4, 5. So 5 will be the dB. Okay. So here the alpha hydrogen was 2. Here the answer will be 5. 27 is 5. Okay. Next, 28. Hmm. Which of the following gives positive test with 2,4-DNP? 2,4-DNP can give all these compounds are positive test. Okay. So answer should be 4. 29. In which of the following reaction aldehyde will form Stephen's reaction? Okay. So nine. In which of the following reaction aldehyde will form? Oh, sorry. And option A is called Stephen. Option B, Ettard. Option C, Caterman. Option D, this one. Okay. So all the 4 compounds are giving aldehyde. Okay. So answer should be 4. Next, 30. Which of the following compound is or are hemiketal? Okay. Hemiketal is this one and this one. 2 compounds. Answer is 2. So the 2 compounds are this one, OH and OET. And this one, OH, OET. So answer will be 2. After 30, 31. Okay. 31 compound is acetophenone when reacted with base C2H5ONA yields a stable compound which has the structure. Okay. So we need to draw the structure of acetophenone. Okay. Acetophenone. So this is a simple aldol condensation reaction. So simple aldol condensation we have to draw like this way. So this is the product. So this product is not hydrogen. There is not hydrogen. So acetophenone they are saying. So CH3 will be there. Okay. So there will be no hydrogen. Okay. So our product should be C. 31 product should be C. 32. A strong base can abstract an alpha hydrogen form. Strong base can abstract an alpha hydrogen. Can abstract an alpha hydrogen. It should be ketone. Okay. It should be a ketone because alkane is not, amine is not. Strong base taken the hydrogen from ketone. Okay. Alpha hydrogen is very acidic. That's why if we using strong base, so hydrogen can be scavenged from ketone. Okay. Next, 33. 33 option B is B product will be what? B product will be benzoic acid. Okay. After that, B product, if we use bromine FeCl3, so we are getting what? We are getting C is equal to COOH, and we are getting here the bromine. Okay. And after that, we are using, if we are using D, okay, if we are preparing D, so C2H5OH. So in that case, C2H5OH, so product mechanism like this. Plus C2H5OH. Okay. So this oxygen have a level oxygen. Okay. Leveling of oxygen. And there is C2H5. Okay. This lone pair We'll attack over here, and this OH get out. Okay, so our product should be double bond O star C2H5 minus H plus, or we can write plus H plus. Minus H plus from here, plus H plus from here. Okay, so we are getting our product, this bromine. Okay, so our option should be A. Okay, next 34. Clemenson reduction of a ketone is carried out in the presence of which of the following? Okay, zinc Hg with HCl, so option B. It's very simple. Uh, Next 35. If 35A is methyl cyanide CH3CN, this is the A, and after A H3O plus they are doing, so CH3COOH, it will be B, and lithium aluminum hydride LiLH4 or ether, so CH3CH2OH. Okay, so this will be C. Okay, so ethanol, so option B, 35 answer will be option B, ethyl alcohol. Alcohol. Okay, next 35, 36. In the reaction does not give benzoic acid. Okay, first one can give benzoic acid, option B NOCl. Okay, it can also give benzoic acid with CHCl3 chloroform. Okay, and option C, it can give, option C is giving benzaldehyde. Okay, CHO, benzaldehyde is given, and in case of D, it also give COOH benzoic acid. So option C is our answer. Why? Because it doesn't give the benzoic acid. Okay, 37, 37, 37 CHO and Cl. So it's normal candy zero thing. Okay, so one should be oxidized and another should be reduced. Okay, so there is a chlorine. This chlorine is completely giving you, so uh, misleading you basically, huh? So in that case, hmm, this is the thing, H2OH, and there will be COO minus. Okay, so your answer should be A. Okay, 38. CH3CHO and C6H5CH2CHO can be distinguished chemically by iodoform test. Why? Because iodoform we know CH3 C double bonded O Z group can give iodoform test, but here in case of C6H5CH2CHO, this compound doesn't have CH3CO group. This group doesn't have the here. Okay, so it can't give iodoform test. So iodoform test can't give. Iodoform test can't give. Okay, so CH3CHO can give. Can give. Can give. Okay. So our 38 answer should be D. Okay. Again 39. 39 reaction by which benzaldehyde cannot be prepared. Okay, benzaldehyde cannot be prepared. Acha, okay, benzaldehyde cannot be prepared. In case of 39, option A, benzoic acid, COOH, benzoic acid, if it reacts with zinc Hg per HCl, concentrated HCl, it will give you COCl, okay, COCl plus H2O. Okay, if I use CrO2 Cl2, okay, option B, if I use CH3 toluene, okay, if we use CrO2 Cl2 in CS2 followed by H plus followed by H3O plus. So we are getting what? We are getting aldehyde, benzaldehyde, CHO. Okay. Option C, COCl and hydrogen palladium barium sulfate, BaSO4. So we are getting what? We are getting again benzaldehyde plus HCl. D. This is a Gattermann reaction, Gattermann-Koch reaction. So CO plus HCl, if we are reacting with, so it is also giving aldehyde and HCl. So here the answer should be A. Why? Because A doesn't give you benzaldehyde. A is giving only acid chloride. That's it. Okay. So last question is 40. Of the following, which is the product formed when cyclohexanone undergoes aldol condensation? Cyclohexanone. Cyclohexanone. So this is cyclohexanone. If it does aldol condensation, self-aldol condensation can happen, right? In case of self-aldol condensation, so there is a alpha 2 alpha hydrogen. You can take any either side. This is alpha carbon. This also alpha carbon. So there will be double bond O, and this double bond O will be reacting with this cyclohexanone, and then if water will be removed, so you are getting the product, this one. So this one will be the product. Okay. So this will be the product. So option should be A. Okay. 40 option should be A. So that's it from my end. Okay. And hope you guys are doing good. Thank you.